What's going on, guys? We got 7.2, day 1, and we're going to try to tack on day 2 in the same video. Solving exponential equations. Okay, our first strategy for solving exponential equations is to use common bases, to rewrite both terms, both sides of the equation, as with common bases and then raised to exponents. So our first example here, starting off easy. 2 to the x equals 8 to the third. Okay? So 2, obviously, that's about as small as it gets. 8, I can rewrite 8 as a power of 2. So we're going to try to get them both to be as a power of 2. So 8 is 2 to the third. So we rewrote 8 as a power of 2. 8 is 2 to the third. So now I have 2 to the x equals 2 to the third to the third. So we got to simplify this over here. Exponent parentheses exponent, that's our power of a power property. This is the one time we get to multiply exponents. Okay, one time that we get to multiply exponents. Alright, so we're going to have 3 times 3 for 9. So we have 2 to the x equals 2 to the 9. Okay, in order for this to be true, our exponents have to be the same. So x equals 9. Okay, that's a pretty basic, pretty easy type of problem, but we're still had to start somewhere. Alright. Go ahead and hit pause and try this one on your own. And try that one on your own. It's a little bit tougher, but I think you can do it. Alright, let's see how you did. Okay. We got a 9 over here and a 3 over here. Alright, we probably want to go with writing these as 3's. Okay, so 9 is 3 squared, okay, to the 2x minus 1, and 3 is already as a power of 3, 3 to the 6x. Okay, power of a power, we multiply, and we have to multiply this 2 to both. So this is 3 to the 4x minus 2. Equals 3 to the 6x. Okay? In order for these two numbers to be equal, alright, these exponents have to be equal. So 4x minus 2 needs to equal 6x. Let's subtract 4x from both sides. Negative 2 equals 2x. And then we'll divide by 2 and get negative 1. Okay? Negative 1. So if I put negative 1 up here, 2 times negative 1, negative 2. Minus 1 more makes it negative 3. So we'll have 9 to the negative 3. If I put negative 1 up here, that should be the same as 3 to the negative 6th. Alright, this will be some big decimals. 9 to the negative third. Okay, there it is. 3 to the negative 6. Ta-da! Same thing. Alright? So that's one type of problem we got. Okay, another type of problem involving exponents that we're going to be working on today. Compound interest. And our compound interest formula is right here. Okay, you might want to pause this to write all this down. I'm just going to read through it. But I can read a lot faster than you can write. Alright, so A equals P times parentheses 1 plus R over N, parentheses, to the N times T. Both of those are up there in the exponent, N times T. P is our principal amount, or starting amount. R is our annual interest rate. You need to change that to a decimal, right? They're going to give that to you as a percent. It's going to be 4% or something like that. You need to change it to a decimal. N is the number of times it's being compounded per year. Okay, monthly is 12, weekly 52, quarterly would be 4. Okay, T is time, usually in years, and A is your ending amount. So if you need more time to write that down, hit pause and write it down. Okay, so here's our little story problem, similar to what we'll have in the book. we're depositing $4,000 at 2.5% annual interest compounded monthly. What is the balance after 5 years? So there's a whole lot of information right there. What was our principal, our starting amount? We're depositing $4,000. Okay, what's our rate? 2.5%. And if I change that to a decimal, remember we slide it 2 spots, this is back to 7th grade math, to 0.025. N, the number of times it's compounded per year. We're compounding it monthly, that's 12 times in a year. And T, what's the time we're looking at? 5 years. Okay, so we're going to put all those numbers up there. So we should have 4,000 times, parentheses, 1 plus 0.025 over 12 to the exponent. We got 12 times 5. Oops, sorry. Okay, now if you want to do a little simplifying before we type this into the calculator, you sure could. Okay, you could do this and combine that. 1 plus 0.025 divided by 12. Okay, maybe you don't want to do that because you're probably going to round that, and then you're going to lose some of these 3's out there, which is going to change your answer just a little bit. And it might not affect your final answer when we round to the nearest penny, but it might make it off by a penny or 2 as well. Okay, we could certainly do 12 times 5 equals 60 before we type it all into the calculator as well. Okay, let's take a look here. 4,000 times, parentheses, 1 plus 0.025 divided by 12. Exponent. Now we want to, and if you have a calculator that bumps it all up to the top, you don't have to be quite as careful. But if you don't, you're going to want to put parentheses around that. Exponent 12 times 5, or you could just do that in your head and call it 60. $4,532, and that's it. We wouldn't round up to the penny there at all. Yep, from the second one. Done? Thanks. Third type of problem for this section. This is a good one. Writing a function from 2 points. Okay, and sometimes these 2 points are just given to you, and sometimes these 2 points are in a story problem and you have to find them. So we're going to do a story problem one because obviously if they're just given to you, you should have your points. You wouldn't have to look for them. Okay, Frank starts an experiment with 2,000 bacteria cells. After 4 hours, he's up to 162,000. Write an equation in the form y equals a times b to the x. Okay, we need 2 points, and we're going to use time for our x value. Okay, so the obvious one here, hopefully the obvious one is 4 hours and 162,000. Hopefully that's an obvious one for us. Okay, the not so obvious one, the only other thing we have is 2,000 bacteria cells, but what's our time with that? What would be our time with that? It's when Frank starts the experiment, so no time has passed, so we're at time 0. So there's our 2 points. There's our 2 points, okay? Now what's really nice about this one, and I think the book gives you the 0 point every time, that 0 comma, this is going to be our a value. Okay? That's always, whatever is with 0 goes in for a. And then you use your second point to plug in for x and y, and then we're going to solve for b. Okay? So we're going to have y, 162,000, equals a, remember our a was up here, 2,000 times our b to the x, 4. So it looks tough, but it's really not. It's really not. Okay, we're just going to divide, and then we're going to do an exponent. So we're going to divide by 2,000. Okay, we should get 81 equals b to the fourth. Okay, how do we solve for b when we have it to a power? We're going to do it the reciprocal power to both sides. So if that's b to the fourth, we're going to do b to the 1/4 to both sides. This is just like doing the fourth root. Okay? When I multiply these exponents together, 1/4 times 4, I should just get b to the first, or just b. Alright, when I do 81 to the 1/4 power, we get 3. And now we can rewrite our equation and finish it off. For your final answer, your final equation, we want to have the letters y and x in the answer, but we want to have a and b filled in. Okay, so we have y equals, our a was 2,000, times our b was 3 to the x. So let's kind of think about what this means here. It means we're starting the experiment with 2,000 bacteria cells, and this times 3 of the x means it's tripling every hour. It's tripling. Okay? That's what that means. So then for day 1, we're just going to go 9 through 21. Page 464, 9 through 21. Alright? And now we're going to get a quick little start here on day 2. It's very, very similar. Very, very similar. It won't take very much time at all. Okay? So the only thing here different between day 1 and day 2 is that now we're doing with inequalities. Alright, same idea. So we'll start off with 16 to the 2x minus 3 is less than 8. Just like with day 1, we want to rewrite as a common base. So 16 and 8, you're thinking, oh, is it 8? Is it 4? Okay, 16 and 8, okay, are not powers of 8, or, well, 8's a power of 8, but 16 is not a power of 8. 16 is a power of 4, 8's not a power of 4. They are both powers of 2, though. 2 to the third is 8, 2 to the fourth is 16. So that's what we're going to do. We're going to rewrite them as 2's. Okay, 16 is 2 to the fourth, 2 times 2 is 4, times 2 again is 8, times 2 again is 16. And then just like with day 1, we need to simplify our exponents, so we multiply. Okay, we'll get 2 to the 8x minus 12 is less than 2 to the third. And in order for this to be smaller than this, I need this exponent to be smaller than this exponent. So 8x minus 12 needs to be less than 3. We'll add that 12 and then divide by 8. And for all the x's less than 15/8, this will be true. Okay? One other little point, if you have a 1 over, okay, 32, 1 over 32. So think about that. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 32 is 2 to the 5th. But how do I do 1 over 2 to the 5th? Okay, it's going to be 2 to the negative 5th. So if it's 1 over a number, it's going to be a negative exponent. Okay, that's the big thing there to remember from our previous lessons. Okay, if it's 1 over, it's going to be a negative exponent. And now it's the same idea. Negative 5 is less than x plus 2. We subtract that 2. Negative 7 is less than x, or we could flip it all the way around and say x is greater than negative 7. Alright. Homework for day 2, listed right here, graded on accuracy. Okay, we had a day 1 with, that's going to be completion. Day 2 there, accuracy. Alright. Thanks a lot, guys. Good luck.